So quantum physics has a reputation. Years of studying just to grasp the basics. Math's so dense, it takes a PhD to get through the door. That's the noise. The signal is the ideas themselves are more accessible than what you've been told. The math is brutal. We're not doing the math. We're doing the idea. And the idea can stand on its own. Here's the most fundamental one. Everything is made out of something, and at some point you hit the bottom, the smallest known unit of anything. That's a quantum system, not an atom. Atoms are made of smaller things. Not a proton. Protons are made of smaller things too. We're talking about the fundamental stuff. Electrons, quarks, photons, the things that as far as we can tell have no interior, no components, nothing smaller inside of them. Bottom of the stack. And here's where it gets strange. The fundamental thing, the smallest unit of anything, isn't a tiny ball sitting somewhere in space. Left alone, it spreads out across space as a probability cloud. Not because we don't know where it is, but because it genuinely doesn't have a single location yet. Some areas are more likely than others. The shape isn't random, it has structure. Certain spots are dense with possibility. Others are completely forbidden, zero chance, not low chance, zero. You can picture it as a 3D shape, in this example like a dumbbell, where the dense center is fully opaque and the edges dissolve into transparency. The opacity is the probability of it being at that point, the particle function. That shape is real, and it's called the wave function. That's the overall shape. Then anything interacts with it. A photon hits it, another particle grazes it, anything, and the whole spread, it collapses into a single point. One location, definite, done. That's the particle function. Think of a ringing bell. The bell is vibrating in all its complexity until you touch it. Contact stops the vibration and forces a single dead state. Quantum interaction works the same way, except with the bell, the vibration was always real. With the quantum system, the single location didn't exist until the interaction created it. That's what breaks the intuition. We call them particles because that's always what we catch, but catching is what makes them particles. The wave exists only while nothing is touching it. And so the way they get that probability distribution is they touch the wave multiple times, and that's how they figure out how likely the particle is to exist on that part of the wave.